if I get a spare minute this afternoon, I might be able to get them done today, but my schedule's pretty packed up this afternoon, so I don't think I will. But you never know, maybe it could get canceled or what have you. And if that happens, then yeah, I'll get them done. And I, you know, I'm gonna get a haircut. I do, thank you. I was really sick. I don't want you to touch it. I don't want you all to get sick.
I don't think I'm gonna be because
you ever get so sick where you just, even your worst enemy doesn't
questions, I did them.
And I don't have any enemies here, so I'm like, man, don't get sick.
Because I got so nervous. I was rushing because I almost
And I was sick all weekend, which, okay, it's not fun to be sick, but if you're going to be sick, it's better to do it over the weekend.
Yeah.
Then you can sit back, watch a little TV, catch up on all the Breaking Bad TV. And then realize that Netflix only has season 1 through 5, the last season, so you have to pay for that one.
Yeah.
Which I'm not going to pay for it, so I wait. Yeah, it's a little bit of money. What do you hand out, Bob? 4?
Yes.
Okay, well, we'll go there. So after Breaking Bad, you can't watch any of that. You can from the Sons of Anarchy and figure that you can't watch any of that either. Come on, that's the way they look. You want $20. And I say no. Do not have my $20. All right, so let's start from here. So the octet rule. Who remembers the octet rule from last time?
It's anything that are not noble gas.
Anything that's not a noble gas wants to become or wants to achieve a noble gas configuration of electron. A noble gas has how many valence electrons? 8. And that's the magic number. Now, the noble gas helium, don't forget, only has 2 valence electrons. Okay, so helium doesn't want to knock it. Helium just wants a duet, which we already have. Hydrogen, if you look at period 1 on top of the periodic table, hydrogen is the only element in the same period with helium. So hydrogen only wants to get 2 electrons. Everything else wants 8. Okay? So hydrogen, this wants 2. Everybody else wants 8. Make sense? Okay? Except for lithium, he only wants 2 as well. Don't worry about that. Okay, so let's take a look at a couple of problems or a couple of things we did last time just to get you refreshed and back in the mood. What if we had the element sodium? Sodium has how many protons? 11. How many electrons? 11. How many neutrons? You don't know. There you go. Good job. See, you guys are ready for that. Yeah? Oh, look at that. Oof. Trick question. Nailed it in the park. Okay. So now, in terms of electron configuration, where are the electrons? So it'll be 2, 8, and 1. Okay? So normal sodium has how many valence electrons? 1. 1 valence electron. Sodium wants very much to look just like a noble gas. So sodium can be all the way over here and gain 7 electrons to look like argon. Or can lose 1, exactly. Or it can dump off its 1 valence electron to look just like neon in terms of electrons. So sodium would like to lose 1 electron. So negative electron. So electron just kind of goes off into space for now. We're going to say it goes off into space for now. Later on I'll tell you where it goes. So now, sodium has lost an electron. So how many electrons does he have left?
10.
10. He has 10 total electrons left. So add that up, you get positive 1. Right? So sodium has a noble gas configuration, but he is not a noble gas. He is an ion. He has a charge. So it'll be Na plus 1, or Na plus. Right? Sounds a little familiar from last week?
Yeah.
This is the noble gas, or the octet rule. Everything wants to gain an octet. Some things will gain it by sharing with each other. Others will gain it by losing or gaining electrons. Okay? What about something like chlorine? Oops. Chlorine is in what group? 17. So chlorine has how many valence electrons? 7. Okay? Equals 7. And it wants to have how many at the end of the day? 8. So it's going to gain one, right? It'll just get one from somewhere. So then, if it gains an electron, it will have valence electrons equal to 8. So now you gain a negative charge, right? So you've gained one electron, which is negative, so your overall charge should be -1, right? So chlorine will go to chloride minus. Okay, so there's two different ways to look at the same kind of problem. I did it one way, this way, the other way I did it that way. So it depends on how you want to look at it. It doesn't matter as long as you get the right answer. Okay, so it's all about filling up the valence shell, or losing some electrons to go backwards in time to the old valence shell. Make sense? All atoms want to do that. Please write that down. Metals form positive ions. In this class, all metals can be neutral or positive. All metals are neutral or positive. Now, all group 1 metals form a positive 1 charge. All group 2 metals form a positive 2 charge. Can be equal to 0 or plus 1. So anything in group 1 could be neutral, no charge, or positive 1. Group 2. Can be 0 or positive 2. So group 2 metals can be either 0, neutral, no charge, or positive 2. Group 13 aluminum only, can be positive 3. Okay? So in group 13 there's one metal, that's aluminum. Oh, there's more than one metal, but the only metal I want to talk about is aluminum. It can be positive 3 or 0. Okay? So group 13 there's one metal we can talk about, that's aluminum. Aluminum can be positive 3. Okay, the other ones below that can be more. So aluminum can be positive 3. So group 1 metals, positive 1. Group 2 metals, positive 2. Group 13 metal, aluminum, can be positive 3. Okay? Now, what about all these metals here in the center? What about all these metals here? Starting from here and going all the way over to here. These are special. And when we get to those, I'll show you how to work with them. But they can adopt more than one charge. Iron, for example, can be positive 1 through positive, I think, 6. Okay? So it's not going to be all those charges at once, but you can have examples of iron with a positive 2, iron with a positive 3, for example. Follow me? So when we get there, we'll talk more about those. All right? But for now, group 1, positive 1 or 0. Group 2, positive 2 or 0. Group 3, aluminum only, positive 3. Make sense? Well, can you accept it? Non-metals. So anything that's a non-metal, except for carbon, from here over. So all the non-metals, they will be negative. The non-metals will be negative except carbon. That's the only exception. We don't talk about carbon as a negative in this class. So all non-metals can be negative. So now, if you are group, what is it? Check before I said the wrong thing. Group 15. Group 15. They can be 0 or negative 3. How do you remember that? How can I remember that group 13 nonmetals can be -3?
You should try 10.
You could do that. Or, without having to worry about math, you could just go -1, -2, -3. It takes 3 jumps to get to the neon. See that? So nitrogen's right here, group 15, or phosphorus, either one. -1, -2, -3. See that? Just count the periodic table. So phosphorus, -1, -2, -3. Does that work? So without even telling you, what can sulfur be? -1, -2. See how easy that is? Bromine can be what? -1. See how you can just use the periodic table? Without having to do any kind of math. You just look at it and go, okay, what's the charge on selenium? Oh crap, selenium. I never saw that before. -1, -2. Okay? Pretty simple, right? Alright, so all group 15 can be 0 or -3. Group 16 can be 0 or -2. And group 17 can be 0 or -1. Okay? In this class, nonmetals will never be positive. In this class, nonmetals will never be positive. In reality, you can form positive nonmetals, and you can also form negative metals. It's weird, but it happens.
Is it chemistry or just this class?
What?
Is it chemistry or just this class?
In chemistry, pretty much anything can happen, but in this class, we don't get into that weird crap.
Okay.
There's no need to get into the weird stuff. Most like academic chemists would like to see that kind of stuff because it's weird and interesting and kind of woo how that happened. But, you know, is it relevant? Sometimes, yeah, but most times no. You know, like you should see some of the molecules that people make. Like, there's a molecule out there that looks like the Olympic rings. You know? It's not natural. It's made by a French group when Paris had, I think it was Paris or whatever city of France had the Olympics. This human scientist made this molecule for national pride, I guess. You know, had no real value, except for it was interesting how they made it. Anyway, that's my whole thing. Okay, so let me just keep going here. We went through all this stuff. I go through a lot of stuff without going through the slide because I like to just ramble, I guess. Ionic compounds. Write that down big, bold type in your book, please. Ionic compound. Very important topic. Ionic compound. Now, before we get into this, while you're writing it down, I want to just ask you a couple questions. On the planet Earth, some molecules are stable, right? Some molecules are not, right? So, for example, I personally don't know of anywhere where you can find fluorine, like the element fluorine. You can find it bonded to things, like fluorine and silicon make a pretty good bond. Fluorine and carbon do too. But you can't just find fluorine that I know of. Okay, you can't find F2, the element fluorine. So what does that tell you about the element fluorine? What? Well, it is dangerous, but it's not really rare. There's fluoride everywhere. But it's very reactive. It's not stable on the Earth. In planet Earth, fluoride atoms are not stable, or fluoride element is not stable. So it's down to something else. So fluorine, for example, or even chlorine, for example, that's probably a better example. There is no place that I know where you can mine chlorine gas. If there isn't a mine for chlorine gas. But there is mines for sodium chloride. Salt, right? We have salt mines everywhere. So chlorine, chloride, the ion, chlorine, exists everywhere. It's predominant, right? But the gas itself is not. So that tells you something about the gas. The gas on Earth is not stable, but its ion is. See what I'm saying? So how do you know something's stable? It's everywhere. How do we know water is stable? It's everywhere. It's on the Earth, it must be very stable because it's everywhere. Okay? How do you know carbon is a stable element? In case you're wondering where you can find some carbon, look at your pencil lead, that's carbon. Carbon's everywhere. It's stable. See what I'm saying? Stable molecules and stable elements. Now, here I showed you this photo before. Here we have two elements at the top, sodium metal and chlorine gas, both very unstable on the Earth. They react together to form sodium chloride, a very stable molecule. That's everywhere. Okay? So molecules will react, molecules and elements will react to form more stable things. Okay? It's a little foreshadowing from when we get to reactions. But just keep that in the back of your mind. Elements and molecules will always react to form more stable things, and I should say if possible. Okay?
Elements and molecules?
Yeah, they'll react to form more stable things. All right, ionic compounds. So a compound is a molecule that has a couple of different atoms at least. So an ionic compound has a positive and a negative. The attraction between the two is called an ionic bond. They have high melting points and they're typically solid at room temperature. High melting points, typically solid at room temperature. Okay. So now, let's have a volunteer. Everyone jump at what? How about you? There we go. There's a volunteer. Next time. We do this, well, do this quite often. Come on, what's your name? I'm sorry. Christina, everybody. Round of applause for Christina. You gotta forgive him, right? Okay, there's your marker. All right. Excuse me. Our markers, I have a red one, she has a blue one, will represent, oh, we should switch, you know, blue is for boys, but it's for girls. Okay, so now, we'll call these our electrons, right? Christina will be sodium, okay? And I will be chlorine. So Christina will play the element sodium, I will play the element chlorine. Christina has got one more electron than she wants to have an octet, so she's looking to deal. She's looking to get rid of that electron. Chlorine, me, I have 7, I want to get 8, right? You with me so far? So, I just happen to walk by, Christina just happens to walk by me. And I say, hey, hey, you got an electron. She's like, hey, hey, yes I do. And we react. So, literally when elements react, they actually will bump into each other. And they actually will hit each other pretty hard. And they have to hit each other in the right way. So they have to hit in the right way and hit each other hard enough. So basically I have to go over here and jack Christina. I'm not going to touch you, but just so you know. And take her electron. So I'm going to rob her of her electron. I'm going to take it. Okay? So I take the electron. So I've taken her electron. We've reacted. Now, I have an extra electron now, so I am what charge? I have an extra electron, so I'm what charge? No, if you have an extra electron, electrons are negative, so you must be negative, right? If you gain an electron, usually you become negative. Not always, but usually. Sometimes you become neutral. So Christina has now lost her electron. So her charge is? She's positive. Now, I have stolen her electron. I am a thief. I will run away from her now because she is going to come and beat me up to get back her electron. Okay? Make sense? So she will come with me. Okay. Follow me. We will be in the solid state now. Now, shoulder to shoulder. There we go. We are touching. Sodium and chloride atoms are continuously touching. We're not connected. There's no connection here. We're not physically bonded to each other. But she is not leaving the electron she gave me. Well, I have it. She's not leaving me in the solid state. Okay? Because she wants to keep her eye on her electron. And she kind of wants it back. Okay? I'm negative. She's positive. We're highly attracted to one another. Okay? Not because she really likes chlorine, but because she wants it back. Okay? She doesn't really want it back, but she just has some remorse over selling it. Okay? So now, we're in the solid state, we're just like this. And we taste good on potato chips. Now, if you dissolve this in water, Christina and I now can kind of flow away from one another. In water. This is in water now. So we can kind of move away from each other. She's not taking her eye off my electron, which is actually hers, but she's kind of okay with the whole water thing. So she's floating around over there, I'm floating around over here. Now, if somebody were to grab me with a pair of tweezers, if that was even possible, and pull me out of the solution, Christina is going to chase me. And she's going to bond back to me. Okay? She's never going to leave that electron. Now you might put her in solution, we might float away from each other, but she's never going to leave it. She's always going to be in the same solution as me. And if we're not in solution, we will be side by side. I'll be holding the electron, she'll be looking at the electron longingly. I want my electron back. Okay? So that's, you can never take it back though, because you're not strong enough, because I'm like really, really mean. Okay? And plus, once you get it back, you want to get it back because you still want to have that octet, right? But now you're positive, and I'm negative. So my attractive force and your attractive force to me are holding us together. And believe it or not, that bond's very strong. The bond is very strong. How do we know it's strong? You can't melt table salt with a candle. Try it, it doesn't melt. You have to use a blowtorch to melt it. Okay? It takes a lot of energy to melt salt. Okay? She'll never leave you. But in water or some solution, we may float apart because we're not physically connected. Okay? Everybody for Christina for being brave. A great actress. All right. That's ionic compounds. So now, write this down for me, please. The ionic formula. The ionic formula has a positively and a negatively charged ion. Okay? So the ions that make up the formula have charge, positive and negative. But the overall charge of the molecule, or the compound, is neutral. So when Christina and I were here, I was -1, she was +1. Together, we balance each other out. Okay? Make sense?
And together you both reach your balance.
And together we both have a full valence shell. Okay? She went down to her previous shell, and I went and filled up the one I had. We both feel comfortable with that because we both have noble gas configuration of electrons. Sound good? Okay, now when you write the symbol, when you write it down, you write the metal first. Now that's true. That's true. I like to say you write the cation first, and then the anion. Okay? So you write the cation, which for most of the time in this class, there's one exception, most of the time in this class, the cation will be a metal. 99% of the time, there's one exception. And we'll get to it when we get to polyatomics. And then afterwards, you write the anion, which in this class is always a nonmetal, or a polyatomic ion, which we'll get to when we get there. Okay? So, cation first, then the anion when you write it. Sound good? Hope so?
The cation is always positive. Right?
Cation is always positive. Anion is always negative. So that's okay? That's just the rules here. All right, so now, here we go. Here's Christina with her single electron. Here is, oh, let's make Christina red. So she goes there. Here we go. There's Christina, and there's her single electron. Here I am with my 7 electrons. And we collide, and I steal her electron. I just take it. So remember I told you that when we were learning about ions, the electrons just flew off into space? They don't. They actually go off to other elements. So here we would get sodium plus Cl and there's Christina's electron minus. And I like to circle my charges. I don't know why. I don't believe it's mandatory, but I just do. Okay, so now we have a positive sodium and a negative chlorine. Okay? So to write that formula, all you really do is you look here and you go, okay, 1 sodium with 1 plus charge. A chlorine with 1 negative charge. So if those two things come together, that will form a neutral, wouldn't it? 1 plus 1 minus. Put them together, neutral. Make sense? So this would be Na1 Cl1. Because the 1 here, the subscript, indicates the number of atoms in the formula. Okay? You with me on that? Everybody? This 1 indicates that there's 1 sodium in this molecule. This 1 indicates there's 1 chlorine in this molecule. Okay? Now, just like in math, we don't write the 1s. Okay? So just remember in math, you don't always put every number you ever come across in your life is over 1. You just never write the 1 because it's kind of it's not foolish, but it's kind of hard to look at. So what you would write is NaCl. And the 1s are just not there, but they're assumed. Okay? If the 1's not there, you just know it's there. Okay? See what I'm saying? All right? So that's how you would write it. It's NaCl. Say it like that formula. Is that okay with everybody? Pretty straightforward, right? I mean, it's not earth-shattering, and you guys are all pretty bright, so. Let's try something harder. Let's try something harder. Everyone got this?
Yeah.
Let's try magnesium and chloride. So now, yeah, this will work. Okay. How about Christina and my other person who wanted to volunteer? You want to come up here? We'll do this. This is kind of a fun one too. Come on up, guys. This one's you. You guys will be chlorine. Okay. So these guys are chlorine. All right. And I'm going to be magnesium. 2 valence electrons. Okay. What was your name? Denise, everybody. And Christina is back again for by popular demand. Okay. So I have 2 electrons. So I'm a metal this time. I'm the magnesium. These are chlorines, and they're looking to make an octet. I'm magnesium. I'm looking to lose 2 electrons. So now, if Shaniza comes over here and says, don't mind if I do, takes my electron. So you're there you go. She took my electron. She's now negative, right? I'm positive 1, but I want to get rid of this other one, right? So now, I have another electron to get rid of. Shaniza has an octet, right? So I'm like, here, take another one. She's like, no, no, no. There's too much heat with one. The police are here now. So she won't take my other one. Like I can try, and she's like, no. So now, Christina's here to take my other one. Okay? Shaniza wouldn't take it. She's full. Her octet's done. So she's like, no more electrons. I can only be negative 1. Christina's like, I'll take it. I'm a chlorine too. So she took my other electron. So she's now negative 2. Does that make, sorry, she's negative also. Okay? Make sense? So now what's my charge? I gave away 2 electrons. I'm positive 2. So positive 2, negative 1. So that's still not neutral, right? Second negative 1. So negative 2 total charge from my chlorines, right? Positive 2, negative 2. Okay? Each one is negative 1. But together, combined, they're negative 2. Does that make sense? So in the formula, it's not going to be MgCl. Because there's 2 Cl's, right? It's going to be MgCl2. Make sense?
So 1 plus 1, the 1 plus 1 makes negative 2.
Yes, the negative 1 and the negative 1 is a total of negative 2. Yep, the 2 of them together add negative 2 to the whole molecule. Okay, very good, guys. Thank you. Round of applause, that's about. All right, so now we have ourselves a magnesium with 2 valence electrons. And here's a chlorine with 7. Here's Shaniza, let's say. I dump an electron off onto Shaniza. So now I have 1 electron remaining with a +1 charge. Plus, now Shaniza has 1 of my electrons. She won't take another one no matter how much I negotiate with her. I guess she's content just having her octet. Now Shaniza's like, no more electrons, can't handle anymore. Christina comes over and saves the day and takes my other one. Now, magnesium can never, ever, ever have a +1 charge. Never. It will always lose 2. If it can't lose 2, it won't lose any. It'll stay neutral. It'll always lose 2. Okay, so that's going to keep on going here. Electrons are flying around, +2 charge there, and then chloride. There we go. And these are negative. Shaniza and Christina are both negative. So now, in order to make up the formula, how many magnesiums do we have right here? We have 1, right? So that'll be Mg. And I'll put the 1 there for now, but we know it's going to go away. And how many chlorines do I have? 2. Okay? Which becomes Mg Cl2. That subscripted 2 means in this molecule there's 2 chlorines and there's 1 magnesium. Okay? Does that make pretty good sense? The little human acting out helps, doesn't it? It's fun too, right, guys? We laugh, we cry. Emotional roller coaster. Okay, so that is how that type of molecule comes together. Now, what if we had a different element? What if we didn't have chlorine? What if we had sulfur? Now, sulfur is right here. Sulfur has how many valence electrons? 6. So how many more electrons does it need? 2. It needs 2 more. So now what if, for example, sodium again. Let's use sodium as an example again. Sodium has 1 valence electron, right? So who wants to help me with this one? Christina! Shaniza! No? Do you want to again? It's up to you. Well, we got 2 actresses in the room. Everybody, you're trying to applause for Christina and Shaniza. Usually I can get other people involved, but whatever. You guys are happy. Okay. Now, we will make Shaniza. You can be the sulfur. Okay? Right? Alright, so you'll be sulfur. You have 6 valence electrons, and you want 2 more. Okay? Okay? So you don't, we're not going to give me electrons today. Okay, so stand right over here. So here's Shaniza. She is sulfur. 6 valence electrons, needs 2 more. Okay? Here is Christina and I. Oh, here, let's do the same color. There we go. Here's Shaniza and I with our electrons. Ready to make a deal. So we're sodium. We're a metal. We want to dump off an electron. Shaniza wants to gain electrons. So she comes by, she takes mine. Boom, gone. She's got my electron. I'm positive 1 sodium now. Yes? She's negative 1 sulfur. She's only got 7 valence though, right? She's got to have 1 more. Now that she's got 7, she's even more jazzed up. She's just got to have 1 more now. So now she beats up Christina in a slug match, or not, and takes her electron. So Christina and I are positive 1. I'm positive 1, she's positive 1. Together, we're a total of positive 2. Shaniza's got a total of how many charges? Negative 2. She's got 8 electrons, negative 2 charges. Right? So 2 sodiums had to come and balance that charge. Because she couldn't steal enough electrons from me. She took 1 from me, and then I got mean, and I wouldn't let her have another one. So then, again, Christina comes, she swoops in, saves the day, gives her electron to Shaniza, and prevents me from being beat up by a sulfur atom. And a girl. Okay? Does that make sense?
Yes.
So, just because we're sodium, doesn't mean that, a lot of people think when they do these molecules that there's always more anions than cations. Not necessarily. The charges are always the same, +2, -2. But here we needed 2 metal ions to come in and balance 1 non-metal. Okay? So it can work either way. Alright? Sometimes you get the misconception that the non-metals always outnumber the metals, and that's not the case. It depends on the molecule. Okay? Is that okay?
Yes.
Alright. Again for my lovely actresses. Alright, I'll pick on somebody else next. Maybe. If no one volunteers, I guess it's back up with you guys. Alright, so that's pretty simple, right guys? It's not earth-shattering, but it's pretty simple. So let's look at this last one we did. We have sodium. We'll now make a bond with sulfur. So now let's do it a different way, a little faster way, because I think you guys are getting the hang of it. So, oh, that's messy. So sulfur. Let's do it this way now. This is like the first couple were just examples to show you what's going on, kind of give you a feel for the understanding of it. Now let's pretend we're on an exam and time is of the essence. Let's go and say, okay, I have a sulfur. I have a sulfur. Sulfur is right here. So I immediately know, because sulfur is right there, is what charge? -2. I know that immediately from the periodic table. So sulfur can only be -2 or neutral. So it's -2 here. And I look at sodium. Okay, sodium's in group 1. So sodium has to be +1. +1. Okay. So the sodium must be +1, the sulfur must be -2. If I put them together, I'll have NaS, but my charges won't be balanced, will they? I'll have -2 on sulfur, +1 on sodium. The charges won't balance. Does that make sense? So now, what do I have to do to balance this charge? There you go. All you can do is add another cation or another anion. So all you can do to balance charges is add more of what you already have. So let's just say I added a sulfur. I said, okay, my charge is not balanced, let's add a sulfur. So now I have -2, -4, yes? -4 and +1. So I'm not getting closer to balance, I'm getting further away. So that can't be right. See what I'm saying? This is kind of the thought process I go through when I balance these things. I say, okay, if I add another sulfur, I'll go to -4. That can't be right. So I'm getting worse, not better. So let's erase that. So let's add another sodium. So my overall charge of sodium now is +2. And sulfur is -2. So that is charge balance. My positives and my negatives are equaling each other. Okay? Everybody?
Yes.
How many sodiums do I have? 2. So the Na2. How many sulfurs do I have? 1. I have 1 sulfur atom with a -2 charge. Or, excuse me, that wasn't even correct. 1 sulfur ion with a -2 charge. Does that make sense?
Yes.
Okay, let's try another one. What if I had potassium and bromine? Okay, so we run to the periodic table. And we see that potassium is in group 1. So potassium can only have what charge? +1. And bromine is in group 17. So it can only be -1. So let's add all that together. How many positive charges do I have? +1. How many negative charges do I have? -1. Right? Does that balance?
Yes.
So the formula would be
KBR.
KBR. K1BR1. All right, let's do another one. Let's do something a little more fun. Let's do magnesium and that's too hard right now. How about sulfur? Look over the periodic table. Magnesium has how many charges? +2. How do you know it's +2? Does what?
Because to get to the
That's true. But how do you know? How can you just look at it and know it's +2? It's in group 2. That's what I say. But you're not wrong. Everyone who said something else, you're right. But I just say it's in group 2, so it's +2. That's all I do. Sulfur is what charge? -2, right? All right, so magnesium is +2, sulfur is -2. So what is the overall charge here? +2, right? What's the overall charge here? -2. That's neutral, yes?
Yes.
So the formula would be? Yes. All right, one more. Make this one a little tougher. How about aluminum and sulfur? A little tougher. What's the charge of aluminum potentially? +3. Aluminum is the only +3 cation we deal with. And sulfur is? -2. Uh-oh. Bro. Now what do we do? Not quite as easy as the other ones, but still not that bad. Give it a try. Try it. Just give it a quick try. It's not hard, but this looks hard. Once you start working it, you'll be like, oh, that's pretty simple. You need harder questions in 1032. Please, Dr. Betts, that exam was far too easy. I want you to make the exams harder next time.
It was already so hard.
I didn't think it was that bad. That's a little long. That was a little tricky, but not hard. Okay. So let's take a look here. Now, we have a +3 and a -2. So now, what do we got to do? Because they have an odd number and an even number. That's weird. Well, what I do, now you guys may have your own little strategy, and if your strategy works, don't change it. I say, okay, a 3 and a 2. The first number they can both multiply or divide into evenly is 6. Right? So they can both divide into 6. So I want to get +6 on this side and -6 on that side. Because they'll both divide into 6 evenly. Okay? So to get +6, I just have to have 2 aluminums. And to get -6, I need 2 additional sulfurs. Now some of you guys said that, I heard you say it. And you may not have used this same logic to get there, but whatever logic you used, keep it. It worked. So this must be what formula? Al2? Everybody?
Yes.
S3. So that literally means there's 3 sulfur ions and 2 aluminum ions in that molecule. Okay? It's pretty simple, right? One easier way? No, do it the hard way. All right, let's try the easy way. This is the, I'll say it this way. This is the way that always works. What I'm showing you now, this always works. What I'm about to show you always works, but you have to really know what you're doing. Okay? Because it will tell you lies, tell you sweet little lies. Okay? And the lie is incorrect, but you have to know how to fix it. Okay? So let's take a look at magnesium and chlorine. You know that magnesium is what charge?
+2.
+2. Chloride is what charge?
-1.
Now, this is called the crisscross trick. Just take the number, just the number, not the charge, just the number, and move it down there, and that number move it over there. So that'll give you Mg1Cl2, which will simplify down to MgCl2. Okay? The charges go away, just the numbers stay, but you just crisscross them down to the subscript. Okay? So that worked, right? That's pretty simple. That's pretty fast too, right? Now, the problem with the crisscross trick and why you must be careful of it. For example, magnesium sulfide, MgS. Magnesium is +2, sulfur is -2. Right? If I crisscross those, I'll get Mg2S2, which is not right. The actual answer is MgS. So what do you do here? You just recognize that these numbers will divide into each other evenly, right? So it's 1 to 1. Make sense? All right. So be mindful of that. There's a few other caveats I have to show you when we get there to transition metals, but for now, just be aware of this. That you can use this trick. It actually works very well. For example, the one we just did, Al plus 3S minus 2. Should be Al2S3. So that's the crisscross trick has a lot of power, but if you're going to wield big power, you better know how to control it, and you just really have to know. Like the magnesium oxide example is one good example where it kind of falls apart, but you can easily modify it to accommodate what you need. Okay, we did all that. Good for us. Naming. So write this down in the title for me, please, in your notebook. Naming and writing ionic formula. So we just done a lot of the writing part. Now we're going to name them. And a little shameless product placement there, a little more sol action going on for you. Okay. Let's jump to what we've already covered most of this stuff. All right, go back. Oh, there we go. Name the ionic compound K2O. So I want us to name that. Now, before we get into naming, how do I know that's ionic? Like, I look at that compound K2O and I say, okay, that's ionic. I know. How do I know it's ionic? You're saying you're all right so far, but that what you're saying already implies that you knew it was ionic. How did you know it was ionic? Okay, that implies that you knew it was ionic. But how do you know it's ionic? What's potassium, a metal or a non-metal? Metal. What's oxygen, a metal or a non-metal? Non-metal. 99% of the time in this class, when you see a metal and a non-metal in the formula, it's ionic. There's one exception, polyatomics, when you have two non-metals. I'll show you when we get there. Okay, so a metal to a non-metal. So a metal, potassium, non-metal, oxygen, it's ionic. So there's two non-metals, it's not ionic. And when we get there, we'll learn more about it. Okay, but a metal to a non-metal ionic compound. So this, MgCl2, is ionic, right? Metal, non-metal. See how that works?
Yeah.
All right. Now when you name ionic compounds, they have a different rule, or different rules that you use than other compounds. The other ones are covalent. They use different rules. So don't get trapped in that. So this is K2O. The element K is what element? Potassium. The element O is what element? Oxygen. Very good. Now, the element O. And that's the element. So the O2 gas we're breathing, that's the atom or the molecular element oxygen. Okay? So that's neutral. There's no charge. H2O, water, that's not ionic. So the water, actually, the oxygen in water has no charge. Okay? This is ionic, K2O. It's a metal to a non-metal, so it has to have a charge. O minus 2 is not called oxygen. Whoa, what? You change the suffix. You change the suffix. And add IDE. So you take out this whole part right here. So you keep the OX and you add IDE. Okay? Only for the anion. So you change the name of the anion. And put a couple of exclamation points by it so you won't forget. Change the name of the anion to I. So now, we look at the periodic table, and you see oxygen there. It's not oxygen, it's oxide. Are you with me? Sulfur would not be sulfur, it would be sulfide. Make sense? Chlorine is not chlorine, it's... Now you all know that one, right? How do you know that one? Sodium chloride, table salt, right? When you go to the store and you buy table salt, you're buying sodium chloride. Write that down, sodium chloride. And circle the chloride. That's how you're going to remember what to do. You all know that one. You all know sodium chloride. Or if you don't, you do now. Table salt is sodium chloride. It's got some other stuff mixed into it, but sodium chloride is table salt. Chloride. Now on the periodic table, Cl is called chlorine. In an ionic compound, sodium chloride, you change the suffix of chlorine to chloride. IDE. That's how you remember it. Don't memorize it, just remember it using things that you already know, like sodium chloride. Does that make sense? Okay. So F is fluorine, so it would be fluoride. You all know that one too, right? You know, you got good teeth, right? Bromine is not bromine, it's bromide. See how easy this is? Iodine is not iodine, it's iodide. Oxygen, oxide. Sulfur, selenium, salibutidide. Selenide, that's okay. We don't usually use selenium here. Nitrogen is called nitride, very good. Phosphorus is called phosphide, very good. See, that's only if it's an anion. Okay? So you only change the name when they're anions. Does that make sense? Or you accept it. That's the rule. That's just how the rule works. Okay? Now, the cation does not change its name. The cation keeps the same name. So here we have K2O. This is called potassium oxide. Follow me?
Yes.
Now, some of you are very, very tempted to say dipotassium oxygen. That's wrong in so many ways. When you're naming ionic compounds, write this down, make a little note to yourself. When naming ionic compounds, I will not use dis, tris, or tetras. When naming ionic compounds, I will not use di, tri, or tetra, T-E-T-R-A, or anything else. When naming ionic compounds, I will not use di, tri, tetra, etc. With penta and hepta and all that other stuff too. For now, just put that. Okay? I will use the, no, just stop there. That's good enough. I will, well, you already know when to use them. You already know. What's CO2 called? CO2, what's it called? Carbon dioxide. So what's carbon? A metal or a non-metal? Non-metal. What's oxygen? Non-metal. When two non-metals bond together, you do use di-tritetra. And how do you remember that? Carbon dioxide. Di. There we go, see? That's when the lights come on and the floodgates of knowledge come in and you're going to ace the course. See how that works? Good for you. I'm glad that you got that. All right, so now, we'll stick with ionic for now. But you don't use di-tritetras and ionics, you only use them in the other kinds. Covalents are called. When we get there, we'll do more about it. So now, let's do these three together. So here we have the top example, CaO. So first of all, what we have to identify is it ionic. We see calcium, and we say calcium is a metal. Calcium's way over here. These are metals over here. Okay? So calcium is a metal. Oxygen is a non-metal. So it's ionic, yes?
Yes.
So calcium, it comes first in this formula. So you know it's going to be what charge? Positive. It's also a metal, so you know it's going to be positive or neutral because it's a metal. Oxygen is going to be what charge? Negative. So it's the anion. So it's not going to be called oxygen in this name, is it? What's oxygen going to be called? Oxide. So the name of that compound on top is? Calcium oxide. Is that pretty straightforward? The second one. Aluminum is a metal or non-metal? Metal. Oxygen is a non-metal. So the name of that second one, B, is aluminum oxide. It is not dialuminum trioxide. It is aluminum oxide. Sound okay? The third one. Give me a name. You got it. I was waiting for you. I heard you talking. Good. Magnesium chloride. So you got it, right? All right, everyone got it? So it's not challenging, is it? It's just you got to know the rules. Once you know the rules, actually it's pretty straightforward how to name things. Okay? All right, let's see another example here. There we go. So now what this little question is asking you to do is asking you to make formulas with sodium and bromine, sodium and sulfide, sodium and nitride, and then do it again with aluminum and bromine, aluminum and sulfur, aluminum and nitrogen. Provide the formula and the name of the compound. So do the formula and then do the name. Okay? Take a few minutes to try this on your own. Work in pairs if you want to, or teams. But just give it a try. If you can do this, you're good. You're going to be very smooth transition into the next topic. your eyes and your shirt.
So you have two negative charges and one positive charge. So you have two negatives here and a positive there. Okay? So in order to balance the charges, you have to have two positives and two negatives. So that must be Na2, yes. Try doing the crisscross trick.
Okay, what's the formula? Those names are great. Good job. It's half the battle. You're doing good. You're doing good. No, you're not. Very good. Very nice. That's the hardest one. There you go. Go pick the name. Oh, look at that. Good job. Okay, those formulas look pretty good. Now give them names. Yeah. Very good. Very good. That's the hardest part. Get the formula together. Okay, and then do the formulas. I'll come back and take a look. Formulas look good. Names look good too. So that was not. Everything else is correct. Good job. Excuse me. Good job. Okay, careful here. Not correct. Try it again. Remember, there's a -2 on the sulfur and a +1 on the sodium. Very good. Should be ID. So then I'll put an I. And here's the I. So we have the L. And then, so you put nitro. Very good. That's it. Very, very small. Everything else is fine. Very small. Yeah, but you're doing well on the formula. That's the hard part. The naming is good. You know?
Yeah.
Looks good. Good job. Yep, up here. It's up here. And, it's nice to know, right? So it's sulfur. Put Na2S. For that one. There was the other two up front. Alright, so yeah, sodium +1 and bromine -1. So that's going to be NaBr. Okay. Now here you have a +1, so -2. So you have to balance the formula. So in order to balance that -2, you must have a positive, right? So the only way you get +2 is if you have 2 sodium. So it'll be Na2S. Alright, so give the other one a try. There you go. Looking good. Good. Get them? Yep, very good. Yeah, looks nice. Yes. Yes, good. Get them? We're close. We're really close. Okay, so here we have one sodium with a +1 charge and one nitrogen with a -3 charge. Okay? And you have to balance the -3. So in order to balance the -3, you have to have 3 positives, right? So it'd be Na3N. Make sense? How'd you do? You can use crisscross trick. Okay. You want to show it? How'd you do? Nice, very good. I'll have it back. Hold that up. And -1 bromine. So the +3 has to be balanced by a negative. So you have -1. How many more negatives do you need? 2. Two more negatives. So you have 3 bromines. See that? So it'll be AlBr3. Pretty good. All right, try the other one. Good. Very good. Okay. Does everyone notice I'm spending an inordinate amount of time with this? Coming around each one of you individually and saying hello?
Yes.
Does that tell you something about the exam? The second exam is coming? The cat on the metal always goes first. Na2S. I would tell you, yours. Let's see yours already? Very good. Very good. Very good. Yes, everyone else is right. Did I see everybody else's? Oh, didn't see yours? Okay. Outstanding. Nice. I saw yours already? Did I see? So it would be Al2S3, right? Yeah, do the crisscross. Okay, very good. And you got some minor things here now. We'll fix them. Be very mindful here. So nitrite is N. This is a little doing a too quick mistake. All right, so did I see everyone? Did I see yours? Did I see yours? Okay. All right, let me go over these real quick, and then we'll call it weekend. All right. So NaBr. Na plus, Br minus. Do the quick crisscross trick. Becomes NaBr, or sodium bromide. That was pretty simple, right? And we have Na plus 1, S minus 2. Crisscross them real quick. We have Na2S, or sodium sulfide. And then we have Na plus 1, nitrogen minus 3. Crisscross them real quick. We have Na3N, or sodium nitride. So the top one was done fairly, I think everyone did fairly well. A few minor errors here and there. The bottom one would be AlBr3, aluminum bromide. Aluminum bromide. And then we have Al3 plus 3 and minus 2. That's a crisscross trick candidate for sure. Al2N3 aluminum nitride. All right, now the last one you gotta be careful with. That one should be S, sorry. S, there we go. That's a little better. That didn't look right. You ever just know something's wrong when you're doing it, but keep going anyway? Al plus 3 and minus 3. You can try crisscrossing it here. Al3N3. Be very mindful. 3's divide into each other. AlN, aluminum nitride. All right, guys. Have a great weekend. I'll see you next week.